Up to now, we discussed regarding two models, right? One is structural model and second one is data flow model. Now we are going to discuss the behavioral model. Here, if you see the marks, uh, before going to the behavioral model coding part, just we will just recap the how marks will work. Okay. Um, this is the marks block diagram. Now I'm going to explain the operation of the marks. Okay. If all the selection lines, basically, if you see here, 8:1 marks has 8 inputs. If it is a n inputs, consider it as a n selection lines and 2 power n inputs and single output, right? This is the marks. Here, if you see 8 inputs, right? Then uh, if you add 2 power 3, then it will come it as a 8, right? So we are taking this n is a selection lines. So we are taking 3 selection lines here, okay, and 1 output. Now comes to truth table. If all the selection lines are 0, what are the value inside the A0 that commit as a output? Okay. When it comes to second row, if it is a S0 equals to 1 and remaining 2 are 0, what are the value inside the A1 that commit as a output? Okay. Like that, you can see all this truth table. Okay. Now we will go through coding part. Now we will see how to write a behavioral model. Okay. Here I am just giving a module and I am giving a name of my module, behavioral model marks. Okay. What are the inputs? Here there is a 8 inputs, right? So I am giving here 7 down to 0, A. And how many selection lines are there? That is also input, right? Here I have a 3 selection lines. So I am giving 2 down to 0, select, and 1 output, right? Output which Y. Okay. Now we are writing in a behavioral model. So I am using here always at the rate is nothing but a event. Here I am considering a star to consider the all the inputs. Okay. Now I am using begin statement. Now I am using a case. Case is nothing but to write at multiple combinations. It is useful here based upon which signal the output will come based upon the selection, right? So we have to find the all the combinations for selection. So I'm putting that selection signal in the case. So what is the size of the selection signal? It is a three, right? So 3 tick, we are representing in a binary. If all are zeros, what is the output? A0, right? Then y equals to A of 0. Now, if it is 0, 0, 1, y equals to A of 1. Now, if it is a 0, 1, 0, output equals to A of 2. If it is a 3 tick B0, 0, 1, 1, y equals to A of 3. 3 tick B 1, 0, 0. This is this is this way I am writing by using the truth table. Here, if you observe, this is selection line, right? So if all the threes are 0, what will be the output? That I am writing, I am assigning to the y. Okay. Now just go back to the coding part. Now we have to write one more combination, 3 tick B 1, 0, 1. At that time, output equals to A5. Okay. 3 tick B 1, 1, 0. At that time, y equals to A6. If it is a all ones, y equals to A7. We have to end the case first. Why? Because First we begin the case, right? That we has to end. After we have to be put end because here we used begin, right? Begin statement. So after that end module. Okay. I'm just saving this code. So I'm giving here mux bn 8_1 dot p. Okay. I'm just saying that code. Uh, Now I will explain. Let's see. Here, selection lines all are zero. It is nothing but uh, A0 will be the output, right? You can see here truth table. Instead of uh, here, all are zeros, A0. If 001, A1, right? Here you can observe in our code also 001, A1, 010, A2. Now our coding part is completed. Now we will see test bench for it. Okay. Before that, we need to compile our code. So I'm giving vlog and file name mux_bm. That's it. Here, if you see, we got one error. Just find it out. Here, if you see here, I missed a semicolon. I'm again saving my code and again compiling. If you see here, our errors were clear. Now we have to write a test bench. So I'm creating one more file. Now I'm giving mux module mux 8_1 TB, my module. When it comes to the test bench, what are the inputs that we take it as a data type as a rich? Okay. In our design, there is a 8 8-bit size of input, right? So I am taking here 7 down to 0, A. And one more input is there. That size is 2 down to 0. And we are considering name as a selection. When it comes to output, we have to be use while um, and while. Here, if you observe the design, you can see it for A, size is 8. For selection, size is 3. For Y, there is no size, right? I mean, if we declare Y, it's defaultly take as a size 1. So I am not mentioning any size here. Okay. Now we have to instantiate our mod design, right? So we have to just copy our design module name and paste it over in our test bench and just give a name. Whatever you want, you can give it. Here I am giving a M1. Now I am instantiating. Here inside the bracket is nothing but our local variable. Outside dot .a is indicates the design variable. Okay. Dot selection and file. Right. Okay. Now we have to be pass some inputs, right? Initial begin and a equals to what is the size of the a? 8, right? And we are passing in a binary format. So I am taking here 80b and I am passing values from A0. A0's place is 0 and remaining all places are 1. Now I am passing the selection line. Our selection line size is 3. So I am passing 3 tick B00. Okay. Here I am giving a delay because if we continuously gives inputs means it may be collide sometime. So for that reason, we are giving some delay. Uh, it means first executed some value. First it passes this value. After it waits some time. Here the time is 10 seconds. After that, it will takes another input. Okay. Now we are passing another input 80 B0 all ones. Okay. Now our selection line is 3T B001. 001. 001. 001. It means 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. 001. this value will print right in output. See here, if it is a 001, what are the value inside the A1 that will be print. Here the LSB bit indicates A0. After that bit indicates A1. This one indicates A2. This one indicates A3. This one indicates A4. This one indicates A5, A6, A7. Like that, it will indicates. Okay. Now we will give one more input. A3P 1010 1010. Whatever you want, you can pass it. Here again, I'm giving something. Okay. This time, I'm passing all ones. It means what is the output? Uh, the A7, what was the value inside the A7 that will print right here. A7 contains 1, so most probably we are expecting that in a waveform y equals to 1, right? So here I was tried only 3 test cases. If you want, you can test all the test cases. Okay. Here first I was begin, right? So I am keeping n. Latest I am giving the end module. Just saving. Here I am giving mux vm pb dot v, because this file in a verilog, so I am giving dot v. Now I am compiling my file, so I am giving command vlog and my module file name mux. What I was given here, you can see here. This we have to be give while compiling mux vm pb.v. After that, just give enter. Here, if you see here, there will be a no errors. Now we have to be simulate our code, right? So for that we have to use Vlsi and module name. This is module name. Okay, just copy that module name and paste it over in terminal and just press enter. Okay. After that, it will open this window. Just right click on it, add to where all items should be done. Okay. Now just press a run. Okay. If you observe this input here, whatever we pass in our test bench, that only it's showing. Just give me one. Here, if you see in this first test case, we are passing selection line is all zeros. It means whatever the value inside the A0 that will print right. Here we are assigning for A0 equals to 0. So for that reason, our output should be 0, right? Now we will check in our waveform. Okay. If you see here, our output variable is y, right? If you see here, we are passing input as here. You can see the input, all are ones, and only in a of 0 place we put a 0, and we are given selection line as all zeros. So for that reason, uh, according to the mux design, the output is becoming 0. Now comes to the second input. Here in input, only a of 7 is 0, remaining all are ones. And we are passing here selection line is 001. It is nothing but what are the value inside the A2. A2 is nothing but A1. This is A1, right? Second bit. That is 1, right? That value comes to the output. If you see here, it's getting 1. Now we will see the third test case. In this third test case, we are passing 101010 as the input, and we are taking selection line is all are ones. So what was the value inside the A7th bit? This is 7th bit, right? Here we are passing 7th bit as 1. So our output, if you see here, our output is 1. This is how we have to be verify